So today we will see the soil. So soil is the unconsolidated cover on the surface of the earth. So you can see here. बहुत आवाज होता है, क्या करेंगे? दूसरे क्लास में चला जाओ तुम, बराबर? બધે અવાજ થાય, જવા દો ને. કેવો અવાજ થાય છે, પેલા માથું ઠોકા ઠોક રાખે છે.
અહીં બેહી જાવ, કોઈ અવાજ કરે તો કહી દેવાનું કે અવાજ ના કરો. એ લેક્ચર ચાલે છે.
Hello. Hello.
Sir.
Yes, sir. Yes, sir.
Yes,
Okay,
sir.
so we will start. So soil is the unconsolidated cover on the surface of the earth. So soil lying on the earth's surface. Soil is made up of mineral particles, organic particles, air and water. So I told that soil is a composed of the mineral particle, organic particles, air and water. Soil is capable of supporting plant growth. You know that we are growing the crops, plant, and it support the plant. Then function of agriculture soil. So anchor plant roots, supply water to plant roots, then provide air for plant root. So there is better aeration. Then furnish nutrient for plant growth. I told that there are 17 plant nutrients are required. Major NPK, secondary calcium, magnesium, sulfur, and micronutrients zinc, Fe, Mn, copper, boron, molybdenum, and chlorine. And release water with low levels of nutrients. So we have seen this chapter, soil components. So there are 4 components you have to remember. Mineral matter 45%, then organic matter 5%, then water and air equally 25%. So totally 100%. So about half of the soil volume is pore space. And when there is more pore space, then there is better aeration, and then better aeration, then there is a better growth of the microorganism and roots. And about half of the soil volume is solid particles. So mineral matter is also solid and organic matter is solid. So among 4 components, organic matter is very important because it is related with the fertility. Then the soil fertility depend on the mineral matter. It is a parent material. If the parent material is good, then your soil is fertile one, and vice versa. Then we have talked about soil texture. So in texture, we are seeing the size of the soil separate or soil particle. So the mineral part of the soil consists of sand, silt, and clay particles. So here you can see that the sand, silt, and clay. So here they have given the size of the particles or soil separate. The amount of each size particle determines the textural property of the soils. So when there is a coarse texture soil, then more sand, less clay. So when coarse soil is always poor, then fine sand is always fertile. So in fine texture, heavy, it is also known as heavy soil. So more clay, less sand. So clay soil or a fine soil are more fertile because it has less sand and more clay. I told repeatedly Then clay is a active particle and the fertility depends upon the clay particle. Then loamy, more even mix of sand, silt and clay. Means equal portion of the sand, silt and clay, 30 to 35%, each sand, silt and clay, then it is a loamy sand. So it is a good soil. Then soil structures. So soil structure means arrangement. I told that the arrangement of sand, silt and clay particle to form aggregate. So organic matter play important role in better soil structure or better aggregate. So organic matter is the glue that hold the aggregate together. So it will combine the particle of sand, silt and clay together, means aggregate. Then large pores, that is a space between aggregate, are filled with air and a moist soil, air in a moist soil. So macropore, it is also large pore, it is also known as macropore, small pores known as micropore. So micropore are more in clay soil, whereas large pore, macropore more in sandy soil. Then I told that there are supply plant nutrients. So macronutrients, that is nitrogen, phosphorus, potassium, calcium, magnesium and sulfur. So among these, NPK is a major nutrient, calcium, magnesium and sulfur is a secondary nutrient. Then micronutrient, chlorine, cobalt, copper, iron, manganese, molybdenum, nickel and zinc. Then where do plant nutrients come from? How the nutrient come in a soil? So decaying plant litter. When you are growing the crops, then we are harvesting the only grain, then other portion straw, then roots and stubbles are remain in the soil. So that thing has been decayed and that converted into organic matter. So breakdown of soil mineral here, also the breakdown of soil minerals, here plant litter, then addition by humans. Humans means human are adding the commercial fertilizer, manure, lime and other things. So we can improve the soil fertility. But you know that fertilizer is a very, very costly input. But at present, you know that one university has been started in Gujarat, Organic Agriculture University. So in Organic Agriculture University, we have not applied any chemical fertilizers. And the advantage of the organic farming or manure or compost, there will be more multiplication of the microorganism. And whatever they produce from the organic farming, it does not contain the pesticide residue. So there will be less chances of the diseases to the human being. And therefore, you know that the price of the organic products is greater than inorganic farming. Means when we are using the chemical fertilizers, then we are getting less price. But the production is greater in commercial fertilizers when we are using as compared to the manures. But in manure, in organic farming, we are getting the quality products. And it is a present need of the human beings. Then recycling plant nutrient. I told that recycling means reuse. So it is a NPK. So it is a cycles. Then breakdown of soil minerals. So here you see that acid, then water. Here zinc, calcium, potassium, copper, magnesium and nickel. So all are the cations. So that has been released and that has been taken by the plants. Then nutrient addition by humans. So we have discussed that commercial fertilizer we are adding in the soil. So nutrients are in the form of that is available to plant, dissolve quickly and nutrient go into the soil water. So you know that when we suppose we are apply the urea for DAP or single superphosphate, then that fertilizer has been dissolved in soil water, and that soil water has been taken by the plant roots and then translocated to the branches, then stems and flowering parts. Then lime. Lime dissolves slowly as it neutralizes soil acidity. You know that when we have this acid soil, then you have to add lime, CaCO3. It releases calcium and magnesium because it is calcium carbonate or magnesium carbonate. Then organic nutrient sources. So manure, compost, sewage slug are the organic nutrients. Decay and nutrient is similar to crop litter. So when we are adding the manure or cow dung or farmyard manure in soil, then it will be decay and nutrient has been released, major, secondary and micronutrient. And that nutrient has been taken by the plant roots. Then the soil solution, I told that the soil solution, the nutrients are dissolved in water and it is called as soil solution. So soil water is a complex solution that contains, soil water contains many types of nutrients. Other trace element means micronutrient. Zinc, Fe, Mn, copper, boron, all are the trace element, all it is a micronutrient. Then complex organic molecules. Nutrient in the soil solution can be readily taken by the plant roots. So whatever the nutrient we are adding this soil that has been taken by the plant roots. So here it is given the example NPK. If the nutrients are remain in the solution, they could all be quickly lost from the soil. So when the nutrients are present in the soil solution, then it will be quickly lost from the soil. Means when the nutrient go below the root zone of the plant, then there is no use and it never available to the plant. But can you hear me?
Yes, sir.
Okay,
Yes,
good.
sir.
Good,
Yes,
good,
sir.
good. Then
Yes,
adsorption. So adsorption, it is a magnet. So here you can see that it adsorbs the ion due to magnetic power. So adsorption refers to the ability of an object to attract and hold particle on its surface. So it is given the example. So it is a particle, correct? So it is a attract by the soil. So solid particles in soil have the ability to adsorb. So soil particle adsorb the water, nutrient, other chemicals. The most important adsorbers in soil are clays and organic matter. And that is why farmers are applying farmyard manure or compost or vermicompost every year or every alternate year to improve the soil fertility. Then surface area of the clay, I told that 1/4 cup of clay has more surface area than a football field. So clay particle has more surface area as compared to sand because the sand particle is greater. Then properties of soil clay. So clay particles are stacked in layers like sheets of paper. So it is a stacked like sheet of paper. Each clay set is slightly separated from those on the either side. Each sheet has a negative charge on it. So each sheet has a negative charge. And negative charge have to be balanced by positive charge called cation. So negative charge ion has been attract the positive charge that is called cations. Then cation retention on soil clay. So all are the cations: calcium, magnesium, potassium, ammonium, sodium, copper, aluminum, and hydrogen. So you can see here the different plant nutrients are present in a soil clay. Then cation retention on organic matter. So here you can see that it is a hydrogen, then low pH 4 to 5, acidic pH. Here the neutral pH means 7, so it is a sweet soil. So the nutrients are present. Increasing pH increase cation exchange capacity of organic matter. So suppose you take the farmyard manure, it is organic matter. When you increase the pH, then the cation exchange capacity is increasing. Then cation exchange capacity. Cation exchange capacity, it is denoted as CEC, is the total amount of cations that a soil can retain. So the exchange of the cations from root to soil solution. So total amount of cations, calcium, magnesium, potassium, sodium, and so on, that a soil can retain. How much cations retained by the soil, that is called cation exchange capacity. The higher the soil cation exchange capacity, the greater ability it has to store plant nutrient. So I told that montmorillonite clay mineral has higher cation exchange capacity as compared to kaolinite or illite. Montmorillonite has 80 to 100 cation exchange capacity, whereas kaolinite has only 3 to 15. And in sandy soil, kaolinite clay mineral is present, whereas in clay soil, montmorillonite clay is present, and that is why clay soils are more fertile than sandy soil. Then soil cation exchange capacity increases as the amount of clay increases. Means when your soil is black soil or when you are adding more clay, then the cation exchange capacity is increasing. And you know that the farmers are adding the soil of the tank because it contains more clay. Suppose you have sandy soil and you add the soil of the tank in your sandy soil, then your soil fertility will be increased because we are adding the clay particle. The amount of organic matter increasing. So amount of organism increasing and the soil pH also increasing. Negative charge nutrient, that is anions. I told that we have seen cation, then we have seen anion. So nitrate, phosphate, sulfate, chloride are the anions. So nitrate has 1 LNC, phosphate has a -2, sulfate has -2, and chloride is -1. So plant will take sulfur in sulfate form, and plant will take nitrogen in nitrate form or ammonical form. So rice crop take nitrogen in ammonical form, and therefore we are suggest to apply ammonium sulfate fertilizer to the rice crop. Suppose you are using the urea fertilizer, then there will be loss, leaching loss of the nitrogen, and it is not economical one. Soil are able to retain some of these nutrients anion. So cation exchange capacity, similarly anion exchange capacity. So from the root, hydroxyl ion is released, and from the soil solution, either present nitrate, phosphate, sulfate, or chloride. So it has been exchanged. Nitrate is exchanged by the hydroxyl. Similarly, phosphorus, sulfate, or chloride. So it is called anion exchange capacity. So retention of nutrient anion varies from one ion to another. So different anion have retention power is separately. Then phosphorus retention in soil, formation of new solid material. So here you see that phosphate and aluminium. Then it converted into aluminium phosphate solid. So when there is a aluminium is present in particularly acid soil, then aluminium phosphate form and the phosphorus is not available to the plant. Means it has been fixed in the soil and we have lost the money of the ammonium single superphosphate or DAP. Then anion exchange. So phosphate has a -2 valency. So here the anion has been exchanged. Then nitrate, retention in soil. So unlike phosphate, nitrate is very weakly held by soil. So it is not held tightly in soil. So it is weakly held. So nitrate does not react from form new solid. So it will not react with the new solid. So nitrate is not held by oxide sulfate. So if nitrate is not taken up by plant, it is very likely to be lost from the soil. And you know that at present the farmers are applying more nitrogenous fertilizer, urea, ammonium sulfate, and so on. So I told you here it is written that when you are applying the nitrogen fertilizer, then it is not taken by the plant, then it will be leached down from the soil and it will mix with the water, and such type of water we are drinking, and it is called as a water pollution. So we have never applied the excessive nitrogenous fertilizer in soil. Otherwise, there will be water pollution. Because you know that we are drinking such type of water because we withdraw the water from the earth and it contains more nitrate. Then moving nutrient from soil to plant. So nutrient on soil, clay and organic matter. So here the nutrients are present in clay and organic matter. Then nutrient in soil solution also present. Then plant root. So I told that when there is a cations, then hydrogen ion, positive ion has been released here. Then whatever the nutrient, calcium, magnesium, sodium, potassium has been taken by the plant. So continuously the plant will take the nutrients. And therefore we are adding the nutrient in soil. So that nutrient has been dissolved in soil and form a soil solution, and that nutrient taken by the plant root for the growth and development.